Subtopic number 3. So this is for interference of transmitted light through a double slits. Okay. So in this subtopic, you have to be able to use this equation here for bright fringes and for this equation for dark fringes lah. So you have to also be able to use this expression and explain the effect of changing any of these variables. Okay. So methods. These two are the methods of obtaining two coherent sources. So firstly, you would put a light source here, and then in front of it you put a single slit, so this would produce a wave, and then put a double slit in front of it, then you will get two coherent sources lah. So they will be moving in phase. Okay, and then for the second one, you can divide it by amplitude lah. So this incident wave will be divided into two waves. So the first one is the partial reflection, and then the second one is the partial transmission lah. So both of these waves are coherent, which is 1 and 2, and will result in an interference where they will superpose. Alright, so for example, Newton's ring, air wedge fringes, and the thin film interference lah. Okay, so I think if you are PDT, I think you will remember this experiment now, which is Young's double slit experiment. Okay, so we can see that the wavefront from this light source falls on a narrow slit S, which is the single slit, and then it will then go through a double slit where we have S1 and S2 lah. So this would be our source number 1, and this is our source number 2 lah. So they are coherent because they originate from these same waves and their distance are equal. Okay, so because of this, an interference pattern will consist of bright and dark fringes lah. So it will be formed on the screen here. Yeah, this is the screen. This is basically what you would see lah when the light from this slit superposes constructively lah. Okay, so the dark fringe would occur when the light from the slits superpose destructively lah. Okay, so destructive would produce a dark fringe kan, and then constructive is for bright fringe. Okay, alright, that basically minimum means they akan produce dark fringe di sini ni. This is dark, so maximum is the bright fringe. Okay, and then right, so this is the derivation. Again, you don't have to able to derive these equations. Okay, this is like during when I was in metric lah, baru kami perlu derive. So this is the equation. So what is it telling us is it is telling us the separation. So this equation is to calculate the separation between central bright and the mth order bright fringe. Okay, mana-mana yang dalam soalan tu minta, kenapa juga ni? Okay, dia minta second order ka berapa order, mana-mana order lah. Okay, so this is so this is the equation lah. M is the order, and then lambda d over small d. So the capital D is the distance between the double slit here and the screen. So that is capital D, and then the small letter d is the distance of these two sources. Okay, so the separation of the two sources berapa? Itu adalah small letter d. Okay, note for bright fringes, m equal to 0 is the zeroth order maximum. Okay, so zeroth order maximum is the central bright fringe. Okay, plus 2, if plus minus 1 is the first bright fringe, so that is the first order maximum. If you are confused, sini. Okay, so the m equal to 0 would produce a bright fringe, that is the central maximum. Okay, and then the second bright fringe is the first order bright fringe. Okay, and then it goes the way what I'm saying now lah. Okay, so 1, 2, and 3. Okay, So, yeah, itu je lah. 0, first, second, third, bright fringe. Tapi yang first is the first order maximum jugalah. Okay, and then this is the equation for separation between central bright fringe and dark fringe. Okay, just now kita cari untuk central bright fringe and bright fringe. Okay, so now is central bright and dark. So the equation is this one. Okay, so untuk dark fringe kita akan guna X lah. Okay, I think I wrote this one wrongly. This should be XM lah sebab kita cari for dark fringe. Boleh tu. Cacat lah deh. Okay. So M equal to 0 for dark fringes. The first dark fringe is the 0th order minimum lah. Okay. And then plus minus 1, our first dark fringe, which is seen here. So our first dark fringe is here, which is the minimum. So that is M equal to 1. So that is our second dark fringe. Why? Because at this central maximum pun, there is yeah, so the first dark fringe is at the 0th order minimum lah. Okay, and then second dark fringe is our first order minimum. So 1, 2, 3, 0, 1, 2, 3. Begitulah. Hopefully you get that, but you will if you do the exercises and see my examples lah. So the equation for separation between consecutive bright ataupun dark fringes, which is delta y, is given here lah. Okay, so delta y is again is the separation between consecutive bright or dark fringes. And then D and small d, I've explained to you that one. It's similar. Alright, so now appearance of Young's double slit experiment. So we need to know what is the effect of each of these variables to the separation between consecutive bright or dark fringe, the appearance of the Young double slit experiment lah. So delta y here depends on depends on the wavelength of light. So it depends on the wavelength of light, the distance apart of the double slits, and then the distance between the slits and the screen. So all three of this has an effect on the separation between consecutive bright or dark fringes lah. So if the wavelength is short, it would cause delta y to decrease if the capital D and small d is constant. Okay, so this would produce fringes that are closer to each other. Okay, so they will be closer to each other. Then if the distance of the slits is diminished, meaning before pemulaan begini the sources, and then after that the distance sudah. Okay, untuk fix D and lambda, okay, so this would cause this would cause the delta y to increase lah. Okay, so delta y will increase sebab they are inversely proportional. And then for capital D pula, kalau both the wavelength and the slit separation is constant, if the capital D is increased, the delta y would also increase lah. Okay, basically delta y is directly proportional to D, delta y is directly proportional to lambda. This is only valid for when either two of these are fixed lah. Delta y is inversely proportional to small d. Okay, all right, now so let's look at when the source slit as here is widened. Okay, so if this source slit is widened, the fringe would gradually disappear, right? So the slit is equivalent to a large number of arrow slits lah, which would produce its own fringe system at different place. Okay, so if kena kasi besar, maksudnya dia akan ada their own system of bright and dark fringe lah, sebab they will be producing its own fringe system at different places. So the bright and dark fringe of different system will overlap, which give rise to a uniform illumination lah. So if one of this S1 and S2 is covered up, the diffraction fringe would appear lah, the pattern. So if you would carry it out in a different medium, for example water, the fringe separation will decrease or increase depending on the wavelength of the medium lah. So if you use a white light, the central bright fringe would be white, and the fringes on the other side here are colored lah. So violet is the color near to the central fringe, and red is farther away lah. Okay, so because why is it like that? Because red has a greater wave of length, whereas violet is the least tidak banyak lah, tidak besar, sorry. It's not, the range of wavelength is not that big for violet lah. Alright, now we are gonna look at examples, and that is on our third subtopic.